Seeing is like real cool, and us humans are great at it. So great a baby can do it. But for some reason, getting a rock that we tricked into doing math to perceive images the way humans do is not so easy peasy lemon squeezy, but it's in fact very difficult lemon difficult. There's a whole field of research called computer vision that's dedicated to trying to get computers to see images the same way we do. Today, we're going to focus on the basics of how to find and match features between images. In later videos, we'll be able to go into deeper topics like how to map your environment around you or how to classify images. Alright, let's jump into the brain of a computer who's trying to figure out whether the content of two images is the same. Whoa, it's pretty dark in here, but it looks like we have two images coming in, and we have to decide whether they're showing the same subject or different subjects. Well, obviously, if we want to tell whether the content between two images is the same or different, we can just take the difference between those two images. Duh. Look, I'll even prove it to you by showing you two similar images, like consecutive frames of a video, and two unrelated frames. And if you average the difference of these two frames, you can see that the similar frames have a much lower average difference than the unrelated frame. Easy peasy lemon squeezy. Wait a second. If we actually apply this method to a video, you'll see that even though the video looks at different things, every frame is not so different from the other one. So our difference metric never really goes up, even though we look at different things. And wait a second, if we look at this picture, which is definitely a picture of the same thing, the difference is still really high. Okay. It seems like taking the difference is not sophisticated enough. We need something better. We're not comparing the right parts of the image together. All right, well, what can we throw away from this image to just compare the important parts of the image, like the subject of the photo? Well, humans are really good at detecting things just looking at the outline of an image. So is there any way that we can just get the outline of the subject of our image? We can! It's a process called edge detection, and a lot of people have found a lot of different methods to look at edges. Usually, it involves looking at the surrounding area of a pixel and seeing whether there's an area of high contrast around that pixel or not. Okay, so now we've got just the edges of our image, which is a lot less information to look at, but we still don't have a way to compare the edges of one image to another image. Because we know that things can be in different places sometimes, we need to separate the subject that we're looking at from its location in the frame. How do we do that? What if instead of looking at all the edges and the entire outline, we look at only the areas of the highest contrast? Things like corners or borders that are going to be in the image no matter what angle or lighting condition they're under. Once we have those single points, we can compare those individual points to each other and see whether any of them are the same or not. There are a few methods of identifying these points, such as taking the edge image and finding the areas of high contrast there. Or you can just start with the original image and go straight into finding corners or areas of high contrast. Okay, cool. So now we have the set of points, but we don't know anything about them. We just know where they are. But how do we actually compare them to each other? What we're going to do is we're going to take an area of pixels around each point and create a description based off of that. And this description needs to be unique enough that it could separate from all the other points in the picture, but also general enough that among different frames, you can still find the same point. There are a lot of methods to create these descriptions. So for simplicity, just imagine that we slap a barcode on them and we'll call it a day for now. All right, so now we have unique points within each frame and a description about them. Let's see if that's enough information to tell whether there's the same content between two images. So we can definitely see that there are some points that are being matched between these two images that are accurate. However, there are a lot of areas of high contrast that I can see, particularly around this outline, that I would kind of expect to be matched that aren't being matched. But still, that's pretty slick, right? Let's see how this final algorithm performs on our video. It's a little bit jittery, but it looks pretty good. You can track the points in between each frame and see that we're looking at one subject first, and then we move on to a different subject, and the points between those subjects are consistent. And that's it. Together, we've gone from a completely naive solution to a way to identify features consistently throughout different frames. Those are the fundamental concepts that are needed to detect features in images. Of course, I glossed over a lot of things, and there's a lot of different methods to achieve each of the steps that we described. So we're going to go deeper into these topics in the next few videos. But until then, check out this video I made on dimensionality reduction, which is a way of extracting features from general data, not specifically image data. Thanks for watching, and I'll see you guys in the next one.